we're going to be working on the quotient property worksheet. So if you're watching this, you've already gone through the product of power worksheet, and now you're desperate to understand what the quotient power rule is. So let's just go ahead and get started. So the quotient of power rule is in short, I'm going to write it up here. If I have a base, and remember, a base is just any number, any identity, and I raise it to a given power, a, but that could represent anything. It could be any number, but if I take a base, raise it to a power, but it's divided by that same base, raised to a different power, then all that means is I'm just going to subtract the exponents. It's going to get rid of this, it's going to get rid of the x over x, it's just going to give me x. And all it's going to be for the exponent is a minus b. That's the quotient of power rule. That's all we're going to be doing with this worksheet. So let's take a look. I've got x to the sixth power divided by x to the second power. All right, this is pretty much exactly what the quotient of power rule is. So what I'm going to do is I'm going to say x, because we're looking at the same base. These exponent rules are ways to simplify the equation to get rid of extra terms that we don't need. So if you've got an x on top of the fraction, x on the bottom of the fraction, you need to get rid of one of them. So that's going to give me x, and I'm just going to copy them down exactly as they appear, 6, and because it's the rule, it is always going to be minus, 6 minus, and now I'm going to write this as it appears, which is positive 2. We're going to have plenty of options with negative numbers, don't worry about that. For right now, I'm taking same base, it's going to be top minus bottom, 6 minus 2, it's going to give me x to the fourth. All right. Problem 1 in the can. Let's keep the good times going. Oh wow, they hit the gas early on this one. All right. Yeah, we started out with one term and we moved on to 3. Well, all that means, really, is we're just going to do the quotient rule 3 times. That's it. That's all we're going to do. We're not going to do anything extra. We're not going to reinvent the wheel. We're not going to do anything crazy. We're just going to do the quotient of power rule 3 times, 1 for each variable. So what I'm going to do, I'm going to separate out each of these variables. I'm going to have and I'm going to have a's on one term, both b's on the other, both c's on the final one. So, all right. Now starting out with the a's, we got an issue here because the a's don't both have both need exponents to work with the quotient of power. Yeah, but the good news is they both have exponents. Thing is, if you have a term on its own, just minding its own business, not doing anything, you can put a 1 up there. And that is exactly the same as, here, I'll just close that up there. I've done nothing to change that term. All I've done is I've given it an exponent to make visualizing the math easier. So I'm just going to use the quotient of power rule, and I'm just going to go term by term by term. And that's going to give me, so I'll do it with the a's first, and then I'll show you, and then just for the shortcut, I'll show you the other ones too. So a to the fourth divided by a to the 1. This is all I'm doing in my head. I'm just showing you the whole process that I'm doing in my head. You can do this process for the other 2 variables, but I'm just going to show you the shortcut that I look at whenever I'm doing a problem like this. But just to prove that the quotient rule works, and to show show how the quotient rule works, I've got a to the 4 divided by a to the 1. That gives me a, because I'm getting rid of the extra base. It's just going to be 4 minus 1, which is going to give me a to the 3rd power. Now I'm not going to write this out 2 more times if I'm just going to be doing a simple operation. If all I'm going to be doing is the same basic integer operation, all I'm doing is I'm changing the numbers, then I don't really need to write it down, do I? I mean, if you want to, you absolutely can. You can always pause the video and work through this, but I'm going to start out with the b's. I've got b to the 10 over b to the 2. So, just like with the a's over here, I'm just going to do 10 minus 2. It's going to give me b to the 8. Same thing with the c's. I know that I'm just going to be using the quotient rule because they're being divided. Exponents are being divided. If exponents are being divided, use the quotient rule. Recognition has never really been the issue with this, with you all. So I know I'm going to be using the quotient rule, so it's going to be 12 minus 3, c to the 9. So all I do now, I get rid of those little dots and combine all the terms together. And that's the final answer. So again, walking through with the a's in very slow detail, I've got a to the 4 divided by a to the 1. So I'm going to use the exact interpretation of the quotient of power rule. I'm just going to use this exact form. I'm going to copy in everything that I need. So I've got a to the 4, a to the 1. That's going to give me, if I use this format, a to the 4, which is x to the a, minus, you're always going to start out with minus. Whatever else happens afterwards, you are always going to start out with minus. Then 1. You copy this over exactly as it appears. So it's positive 1. So now we have 4 minus 1 gives us 3. So I recognize from doing this a lot that when I look at this operation, I know it's going to be 4 minus 1 because I've got the division sign here. I've got an a on either side of like a division line, so I know this is just going to be 4 minus 1, which is going to give me 3. I did the exact same thing with b. I saw b on either side of a division line, and I did 10 minus 2 gives me 8. I saw c, and my voice broke. I was so happy when I saw c, but I saw c on the top and the bottom of the line here, and I knew it was 12 minus 3, which gave me 9. I got rid of all the extra bases, and then that's how I got the answer for this one. All right, let's do another problem. Oh, all right. So you probably see what I reacted to. All right, no big deal. We can fix this. I mean, we can solve this. Well, I mean, I guess we are going to need to fix it too. First step I'm going to do, I'm going to separate out all the like terms. I'm going to put all the x's together, all the y's together, all the z's together, and then these numbers together. So. All right, if you can follow my chicken scratch, I assure you I worked in a hospital and I was known as having perfect penmanship while I worked in the hospital. So I've got, well, all I've done is I've separated out the like terms and I've put them together so I can deal with them one at a time. Now, negative 12 over 9. I know I've put out a fraction video where I take care of reducing fractions. So hopefully by now you should recognize that I can simplify this because they are both multiples of 3. 9 is equal to 3 times 3, 12 is equal to 3 times 4. I'm not doing anything with the negative, I don't need to. So this should give me negative 4 over 3. All right. So the fractions are simplified. Again, if you're having an issue with that, check out my Unit 0 videos, which are also going to be linked on the YouTube, how to reduce fractions. This is an improper fraction where you have a bigger number on top, but I'm sure you can work it out. Next, I'm going to worry about the x's. I've got x to the 8th divided by x to the 5. I've got the same letter x on top and the bottom of the division line, so all I'm going to do is subtract the exponents. 8 minus 5 is 3. Next, I've got y. Same thing with the x's. I've got a y up top of the division sign. I've got a y on the bottom of the division sign. If that's the case, all I do is I subtract their exponents. 5 minus 4 gives me 1. Now, I've moved over to z. Again, I have z on top of the division line. I have z on the bottom of the division line. That's going to give me 11 minus 6, which is going to equal 5. Now here's a detail. Now, at this point we need to simplify things out a little bit. I don't know where you are in terms of the simplification rules, so I'm just going to show you where I am right now in the hopes that you probably, hopefully, have a better process worked out by now. But anytime you have a number like this, a simplified number, you've done the exponent rule, you've gotten rid of the extra base, anytime you have a number like this with a positive numeral, with a positive exponent, you treat it as though it's over 1. Over 1, over 1 as a fraction. The reason that I made it over 1 as a fraction is because, first of all, it doesn't change anything really. But what it does is it makes combining this fraction a lot easier, especially when it comes to simplification. So what I'm going to do now is I'm just going to multiply all these together and combine all the terms. It's going to give me negative, where is it? There it is. Negative 4 x cubed y z 5 over 3. So all I did was I multiplied the top all together. 4 x cubed y times z fifth equals this, divided by 3 times 1 times 1 times 1, which is 3. That gives me my final answer. You'll notice y to the 1 doesn't have that exponent. Depending on how much a stickler we're going to be for the assessment, as far as I'm concerned, you can leave it at y, or if you put y to the 1 as part of your simplified answer, that's fine too. I don't think it's really that big of a deal at this level, but all that matters is you get the bases with the correct exponents, you get the fractions in the correct form, and you're good to go. All right, next one. All right. So again, we have the process down. All we're going to do is we're going to separate out each of the factors. These numbers are their own factor. They are their own thing that we can evaluate separately. So I'm going to exclude them from our variables. I've got A, B, and C, so I go A, wow. All right, first step, I'm going to take a look at simplifying this fraction. Now, if you watch my fraction video, you should know that immediately I look at this and I know it's divisible by 5. If you don't know why I know this, watch the fraction video. I think you'll be surprised. So I'm going to divide the top and the bottom by 5. And then there we go. So that one is reduced. There's nothing more to do with that. So I know I'm going to be doing the quotient of power rule because the quotient of power rule worksheet, but also because I've got this dividing sign. I've got a base up top, I've got a base up bottom, I've got a dividing sign. So that means I'm just going to subtract the exponents. I'm going to go 6 minus 3, which is going to give me a 3, a to the third. There we go. Same thing with b. I'm going to go with b to the 9. I've got b up top, b at bottom. So I'm going to take 9, so I'm going to take the top exponent, subtract the bottom exponent. That's going to give me 9 minus 9, which is going to give me b to the 0. Uh-oh. B to the 0 sounds like a problem. I mean, that sounds like, how do you get something to 0 power? I mean, a number on its own is equal to something, is equal to itself to the first power. But what does it mean to have a number raised to the 0 power? If you have any number raised to the 0 power, if you have any number, if you have any number, anything, if you have anything at all raised to the 0 power, if you have one of these problems raised to the 0 power, all it does is it changes it to 1. So x to the 0 equals 1. The number 5 to the 0 power equals 1. Y to the 0 equals 1. Pi, mathematical constant, to the 0 power equals 1. So anytime you see anything raised to the 0 power, it is always going to equal 1. Not 1 in the exponent, not 1 in the exponent, 1. It is always going to turn everything into 1. Now, let's move on to C. We have C, I know I'm using the quotient rule. I've got C up top, C at the bottom, so I'm just going to subtract the exponents. 12 minus 11 is going to give me 1. All right. Now I'm just going to combine everything. I know that I've got a positive exponent here, so I'm going to draw the 1. This is a 1. It is not b to the 1, it is not a to the 1, it is not 5/4 to the 1, it is not anything to the first power. It is simply the number 1. Put 1 there. And because this is a positive power, I'm going to put 1 here. Again, this fraction step isn't absolutely necessary. I'm just doing it in order to make combining all the fractions together at the end a little bit easier to visualize. So I'm just going to multiply everything across the top first. So 5 times a to the third times c to the first. And that's it. It's like 5 times a to the third times 1 times c to the first. I don't have to include that 1. Multiplying anything by 1 is just itself. So I can just leave that out. I leave it out now that I know it's 1. And I know it's 1 because it is a variable raised to the 0 power. Because anything raised to the 0 power equals 1. Not 1 exponent, 1 the number. So, and then 4 times 1 times 1 times 1 gives me 4. And that's going to be our final simplified answer. Oh, thank goodness. All right, after all that, back to the single variables. Well, I mean, we've been doing triple variables the last couple problems. We've been dealing with coefficients the last couple problems. We've been raising things to the 0 power, which turns them into the number 1. It's nice to have just a simple example here. So again, we're going to use the quotient rule because we have this dividing, because we have this little division sign. And I've got a base up top, a. I've got a base underneath, a. And so that means I'm just going to subtract the exponents. 20 minus 13 equals 17. There we go. That's the final answer. And it's the exact same process that we've been doing with the more complicated examples. With more complicated examples, the only thing that's different is that we have more variables we got to work with and probably a fraction. But we're doing the exact same process every single time. I have a number up here raised to a power, the same number underneath the division sign raised to a power. All I'm doing is subtracting top minus bottom. That's giving me, I'm just subtracting the exponents. 20 minus 3 is giving me 17. And that's the correct answer. I talk way too much sometimes. All right, so again, we know the process on how to solve this because we've done it before. We've done it a bunch of times before. So all I'm going to do is I'm going to separate out the variables so it makes it easier to visualize what the operation is. So that gives me don't let the large numbers throw you off. We're doing the exact same thing that we've been doing. We're doing the exact same thing that we're going to do. And it's the exact same operation every single time. It's this thing. It's the quotient of power rule every single time again. So I'm looking at the x's. I know I've got x up top, x up bottom, and it's a division sign, so I know I'm going to be using the quotient of power rule. If I've got base on the top and the bottom, all I'm going to do is subtract the exponents. 12 minus 4. So in this case, it's going to give me x to the 8th. All right, let's move on to the y. I've got a y variable up top. I've got a y variable in the bottom. So all that means is I'm going to subtract the exponents. 30 minus 10 is going to give me 20. The numbers look intimidating, yes, they're much bigger, but that just means that it's the same exact operation. You're not changing what you're doing, you're just changing the numbers that you're subtracting from. So I've got z's. I've got z to the 18 divided by z to the 6. So I've got a base up top, I've got a division sign, I've got a base at the bottom, so I know I'm going to be using the quotient rule. Quotient rule just means that I take the top, subtract the bottom. I'm just subtracting the exponents. 18 minus 6 is going to give me 12. Now all I'm going to do, I'm going to just put these together to get rid of the little multiplication signs. It's really more of a formatting thing. I'm not really doing anything mathematically. I'm just cleaning it up to look better. And there you go. X to the 8th, y to the 20th, z to the 12th. And that is our correct final answer. All right. All right, we've got another one with coefficients and 3 variables. But we're not going to panic. We're not going to freak out because we've frankly done this like at least 3 times before. I mean, it's the exact same process again, but again, we've done this a bunch of times before. The first step that we're going to do, that we've done a bunch of times before, is we're going to separate out all of the like terms. So that gives me 15 over 10. Now, I'm going to look at just the r's. 11 r squared, okay. Next, I'm going to take just a look at the s's. S to the 24 over s to the 4. Finally, I'm going to take a look at the t's. And again, these numbers look big and they're meant to be intimidating or make you think that there's more to it. It's not. It's the exact same process that we've done, the exact same process that we've been doing. So, let's get to it. I'm going to start out by simplifying the fraction. Again, you should check out the fractions video located in Unit 0. But I know that these are evenly divisible by 5. So I'm just going to divide the top and the bottom by 5. There we go. Problem simplified. Next, I'm going to look at the r's. I've got division, r on top, r on bottom. So that means all I'm going to do is subtract the exponents. 11 minus 2 gives me r to the 9. Going to do the same thing with s. I've got s up top of a division, s at the bottom of a division. So all I'm going to do is subtract the exponents. 24 minus 4, s to the 20. All right, got that knocked out. Next, I'm going to do the same thing with the t's. I've got t above, I've got a division sign. I've got t raised to a power on the top, t raised to a power on the bottom. So all I'm going to do is I'm going to subtract the exponents. 16 minus 16 gives me 0. Now, again, anytime you have something raised to the 0 power, it turns it into 1. It doesn't turn the exponent into 1. It doesn't turn the coefficients into 1. All it does is it gets rid of this variable. T to the 0 is equal to 1. So it is so much equal to 1. It is so equal to the number 1 that anytime you see anything written to the 0, may as well erase it and just write 1. Notice, t does not exist anymore for what we're doing. For what we're doing, there is no more t. T to the 16 divided by t to the 16 equals 1, and so that's what we've got. All right, now that we have all of the simplified components, we've gotten rid of all the extra bases, we took care of the quotient rule with all of the different exponents, we are going to combine them all together. So again, positive exponent, I'm going to put a 1 on the bottom, positive exponent, going to put 1 on the bottom, and 1 over 1 is the same as 1. So all that means is, all I'm doing is I'm putting 1s here in order to help visualize the fractions to help make them a little more easier. So 3 times r to the 9 times s to the 20 times 1 is equal to 3 r9 s20. I'm not even including the 1. And then the bottom is 2 times 1 times 1 times 1, which is 2. And don't forget your negative sign. And the negative sign came from over here. So that's pretty much it. So that will give you your final answer. So once again, we see it, we're breaking up the like terms. I personally like to start with the fractions, and I go left to right, simplify the fraction, and then just use the quotient rule each time. All right. Alrighty, we've got 9 times x to the 20, we got 9x to the 20, y to the 40, z to the 9, divided by 6x to the 20, y to the 20, z to the 7. Again, the exact same process that we've done, exact same process that we are going to do. I'm going to separate out the like terms first. All I'm doing is I'm separating them out. I'm not doing any of the math, I'm not doing any of the identification, I'm not doing anything else. All I'm doing is I'm just separating them out so they're easier to deal with one at a time. Well, in dealing with them one at a time, 9 over 6 simplifies to 3 over 2. Just take my word for it. Next, I've got x to the 20 divided by x to the 20. So we know we're using the quotient rule because we've got a division, we've got a base raised to a power, we've got another base raised to a power. So because we're using the quotient rule, we know we're just going to be subtracting the exponents. So it's 20 minus 20, which gives us x to the 0. Because we have x to the 0, it turns the entire term into 1. It doesn't turn the exponent into 1. It doesn't turn this into 1. It doesn't turn any of the other exponents into 1. It turns this whole thing, it turns this whole x into 1. It's like x to the 0 means that x is gone, and all you have left is a 1. If you don't even feel comfortable writing the 1, since we're getting rid of it anyway, then just stop writing the x's. If in this case you have a x over 20 divided by x over 20, just stop writing x's. You're not going to anymore for this problem, so just don't worry, just cancel them out and move on. So for y, I've got a quotient rule here because I've got a division sign. Y to the 40 divided by y to the 20 just means that I'm going to be subtracting the exponents, because that is your quotient rule. So that gives me y to the 40 minus 20 gives me 20. Dealing with the last coefficient, z, I've got z to an exponent divided by z to another exponent. So that means I'm going to use the quotient rule. So 9, I'm just subtracting the exponents. 9 minus 7 equals 2. Now all that's left is simplifying. Because I've got positive exponents, I'm putting them over 1. And then that's going to give me 3 times y to the 20 times z squared divided by 2 times 1 times 1 times 1, which is 2. Why did I not include the 1? Because this is all multiplication. If you multiply anything by 1, it's equal to itself. So you just ignore the 1. Why aren't there any x's? Why didn't I just include x to the 0 as part of the answer? I could, but it wouldn't be a simplified answer. If you wanted to do this and then include at the end x to the 0, I don't know where we are in terms of this unit, in terms of like, would you get full credit for the answer, would you not get full credit for the answer? All I know is that this is not completely simplified. This can be simplified by just doing this. And there you go. It is a fully simplified answer by getting rid of that variable raised to the 0 power. Alright, I think that's, alright. Next, we've got a review for the product property. Alrighty, so for the first problem, we're going to be reviewing the product property. Now the parentheses are thrown out there in order to throw you off. The only time parentheses are ever going to matter is if you have an exponent outside of the parentheses. So that's saying that everything inside the parentheses is raised to a power. If you don't have those, if you don't have any exponents outside your parentheses, then the parentheses just mean multiplying together. Then what that means is you can do this. And it's the exact same thing. If the parentheses do not have any exponents attached to them, if you don't have something with inside of parentheses raised to an exponent like this, then all it is just multiplication. It's just straight multiplication all the way across. So because it's just straight multiplication all the way across, since I know my parentheses don't have any exponents attached to them, let me redraw that just to show you what I'm talking about. So I've got this term inside of parentheses, no exponent. So no exponent. I've got this term inside of parentheses, no exponent. So I don't have to worry about the power of power rule. I don't have to worry about that at all. All I need to worry about is multiplying all of these terms together using product of power rule. Because I know it's just the product of power rule, that means that I can rearrange these to make it easier for me to use the product of power rule. I'm just going to put all the like terms together just the same way that I do with the quotient of power. It's just going to look different because I'm no longer dividing. All right. Mathematically speaking, because all of this is multiplication, all that means is that I can multiply all of these together. I can put everything together that's similar. And so that makes it a lot easier to visualize what I'm doing with the problem. Makes me less prone to errors. It's an extra step that makes sure that you get the correct answer. So to start out with, negative 3 times 4 gives me negative 12. That's simple. We know what these numbers are, so we can multiply them together, we can evaluate them, and that's where they're sitting. Next, we're going to look at the x's. The product of power rule says that if I have a base raised to a power multiplied by the same base raised to a different power, that all I do is I add the exponents. When it's a quotient of power rule and you've got division, you subtract the exponents, but again, when you're multiplying them, you're going to add the exponents. So in this case, I've got x raised to an exponent, and I've got second x raised to another exponent, so I'm just going to add the exponents together. 6 plus 2 gives me 8, and that's it. Next, we're going to move on to the y. I've got y raised to an exponent times y raised to a, this one doesn't have an exponent, except you know it does. You should know it does by now. Anytime you have a number just hanging out on its own, it can be a variable, it can be a constant, it can be a whole number, it can be anything. If it's just hanging out on its own, you assume that it has an exponent of 1. And I'm going to do the same thing with z, because you probably don't want to hear me explain it again. So y to the 1, so this y here, up at the top, you're looking at the original problem, is on its own, minding its own business, so it gets y to the 1. Z over here, minding its own business, gets z to the 1. And that's where these 1s both came from. So now I'm going to use the product of power rule, because I've got a base raised to a power times another base, a base raised to a power times the exact same base raised to a different power. And all I'm going to do is add their exponents together. 2 plus 1 gives me 3. Now, for the final one, I've got z raised to a power multiplied by z to another power. All I'm going to do is add their exponents. So z to the 1 plus 4 gives me 5. Now these answers are already simplified, but in order to clean this up a little bit, I'm going to get rid of these multiplication signs here in the middle. And that's your final answer. Your final simplified answer. So, let's take a look at another one. This is also going to be a product of power rule. All right. So again, what am I looking for? Anytime I see parentheses, I know things are going to be multiplied together. But what am I looking for whenever I see a parentheses for a problem like this? I'm looking to see if the parentheses have an exponent on the outside of them like this. Because if they do, there's an extra step. But neither of these do. But neither of these have an exponent in front of them. So what that means is all of this is just this times this times this times this times this times this. And if it's that kind of operation where it's just one thing times another times another times another, you can reorder them any way that you want. So that's why I always reorder the like terms together to make the product of power rule a little bit easier to work with. So I've got all right. So I've got 3 times 2 times a to the 5th times a times b to the 8th times b to the 3rd. I'm going to assume that you were paying attention the last several hundred times I've done this. I'm just going to throw a 1 on the a and hope that you're with me and that I don't have to repeat why I put the 1 there. So I'm going to start out with the numbers because they're the easiest to work with. 3 times 2 is 6. All right, problem solved. Now I'm going to use the product of power rule, which means I have a base times the same base, and they're both raised to exponents. All I'm going to do is add the exponents together. So 5 plus 1 gives me a to the 6th. B, same thing. I have a base raised to a power times the same base raised to another power. All I'm going to do is add their exponents. 8 plus 3 gives me 11. All right, that takes care of all the extra bases. Now I'm just going to get rid of those multiplication signs to simplify. And there we go. 6, a to the 6th, b to the 11th. And that's going to be our final answer for this. All right, last one. All right, so again, the parentheses are thrown in there in order to confuse you, in order to throw you off. But they don't mean any, but in this case they don't mean anything. They're meant to throw you off because you're like, oh, do I need to resolve what's inside the parentheses first? Do I need to worry about that? The only time you have to worry about those parentheses, as I mentioned a couple times by now, is if you have all the stuff inside the parentheses. If there's an exponent attached to it, you have an extra step you have to do. But if there isn't, if it's just parentheses on their own, then all this is multiplication. And if it is just multiplication, then that means you can rearrange the terms however you want to. So I'm going to rearrange the terms to make it easier to use the product of power rule. All right, so product of power rule, we can start out with x. If I have a base raised to an exponent times the same base raised to a different exponent, all I do is I add the exponents together, x to the 11. And that gets rid of all the extra bases. Now I've got to deal with y. So I've got a base to an exponent times the same base, y times y, raised to another exponent. All I'm going to do is add the exponents together. So I've got 4 plus 9 gives me 13. In order to simplify this, I'm just going to get rid of the multiplication sign there. So that gives me x to the 11th, or the 13th, and that's the final answer for you. So again, a lot of these questions, a lot of these operations are just a matter of figuring out what the rules are and then following the process over and over and over again. In order to get rid of the extra bases, in order to simplify the equations, it's important to remember what the rules say and what the rules are asking you to do. You don't have to do anything too creative. You don't have to do anything. If you're doing stuff that involves you inventing new numbers or manipulating numbers, all you have to do is focus one term at a time, one step at a time, one rule at a time. And whether it's the quotient of power or the product of power, you'll get through these just fine.